Hello and welcome back. Today we are going to be doing some balancing equations and naming types of reactions, right? So I think I'm just going to do two of these because these are also in your final exam review, right, on Blackboard under Unit 5. So you do have these answers and how I figured them out, but I figured, why not? Let's go through it. I'm going to skip number 1 because that one's kind of simple, but this might be a good idea. We could try to name this type of reaction. So looking at number 1, without balancing, just looking at, hey, I have one thing plus two things, and it's combining into one single product. Looking at that, this is the general structure of a combination reaction. Combination reaction, RxN is reaction, or you could call it synthesis. Either one, totally fine. Several names for it. But that's a combo reaction. You have two reactants, 1, 2, and you get one product. Awesome. So how about this second one? Let's try to balance this and give us the type of reaction that it is. So I'm going to come over here and I'm going to make my little chart. I have reactants on this side, products over here, and I'm just going to count. I'm going to count how many are on each side, right? So I have one calcium. I have one carbon and 3 oxygens. So it should be that we have the same elements on the other side as well. So looking, and sorry about this is a formatting issue. This is a, yields symbol, an arrow, or it should be. So looking on the product side, I have 1 calcium, I have 1 oxygen here, and 2 here, which gives me 3. And then, oh my God, I have 1 carbon. So this is already balanced. So you don't have to put any coefficients here, but if you wanted to know, this is an already balanced equation. Fantastic, 10 out of 10. So the next step would be, hey, what type of reaction is this? I got no idea. But look at it. It's kind of the opposite of the first one we did. It has one reactant, one big compound that is breaking down into 2 smaller products, right? 2 smaller products. So this would be known as a decomposition reaction. So this is decomp. One thing breaking down into 2. Amazing. So let's try this next one. I think 3 would be good to try and balance, right? And again, this symbol, this is a yield symbol. So our reactants over here, products over here. Let's make a chart. Reactants, products. On this side, I have 2 carbon. I have 6 hydrogen. And I have 2 oxygen. Over here, I have 1 carbon. 1, 2, 3 oxygen, and 2 hydrogen. So the first thing I see here, I'm coming and I see, hey, I have an odd number. So if I look at my oxygens, 3 is an odd number. I'm not digging it. We don't really like these odd numbers, especially if it's paired with a 2. So personally speaking, I think the oxygens are something that I would try to balance first, right? Unfortunately, on the product side, they are split up. So I think the first thing I could do is I'm going to look at this CO2 right here on my product side, and I'm going to go, hey, I know that my carbon has to be doubled, and I also get to hit oxygen with something. So let's put a 2 here. Let's see how that works, 2. So for carbon on my product side, that now doubles it, and we're balanced. And let's see what it does. What does it do to my oxygen? It gives me 4, 5 oxygen. So we're kind of running into the same problem here. Right? We got another odd number. However, I could come over on the other side and I could go, hey, what's up over here? What can I change over here to get this to be 5? Unfortunately, nothing. But what if I put a 3 here? Because I know that 3 times 2 will give me 6. And that gets me kind of close to 5. And I do still have an independent oxygen over on the product side that I can manipulate. So we're starting to balance. I'm looking and I see, ooh, my hydrogens. My hydrogens are very unbalanced, right? I got 6 on reactants, only 2 on products. So I'm going to come over here to H2O and I'm going to try to balance hydrogen. That would involve me putting a 3 here. A 3, right? So that would give me 6 hydrogen, 1, 2, 3 oxygen, plus 4 oxygen. 3 plus 4 is 7. Okay, so everything is balanced right now except my oxygens. What am I supposed to do with this? So I'm thinking that I'm going to have to start doubling up on other things, right? So let's try and make this a 4. Let's see how that works in front of O2. So instead of a 6, this now becomes an 8. Oops, sorry, it's getting a little messy. It is what it is. I have 8 there. And you know what? I think I'm going to double my C2H6 because I'm not seeing that there's a way that I can easily balance this. So double C2H6, see what happens. 4 carbon on this side. Now I have 12 hydrogen over here. And I have put us off balance again. But this does give me an opportunity to rebalance things. So I'm going to come back over to my carbon dioxide, my CO2, and I'm going to go, hey, 4 question mark? Let's see, 4 question mark. So on my product side, now carbon's going up to 4. We are rebalancing. And then oxygen, 2 times 4 is 8, 9, 10, 11. Still not a nice number, but that's all right. Lovely. Okay, so we're at a standstill again. And I need to rebalance my hydrogens on my product side. So instead of this 3, I'm going to cross that out with my H2O. And I'm going to say, hey, I need 12 hydrogens. What gets me there? Maybe 6? So in that case, look, I got 12 hydrogens, but now, again, my oxygens are getting rebalanced. So I already had 8 from my CO2, and now I have another 6. And you know me, I'm not very good at math. I got to do 8 plus 6 in my calculator, apparently. So instead of 11, now we have 14. But you know what? This puts us at an advantage because I finally have an even number on my product side. Finally. Which means that I can come back over to O2 in my reactants and I can say, hey, what times 2 is 14? 7. 7. And now we are balanced. I know this one was very long. These types of problems usually are, but I think it's good to see that sometimes it is a process and it takes a minute to get there. So our official coefficients will be 2, 7, 4, 6, right? So the last part of this will just be, hey, what type of reaction is this? So in this one, I'd like you to pay attention specifically to these products, CO2 and H2O. These products always indicate a combustion reaction has occurred. Combustion reaction. So you will know if the only 2 products you have are CO2 and H2O, then you're good to go. You're good to go and you have combustion, right? Okay, so that was a really long one. I totally understand. But I still do want to move on and do this next one because I think it's also another good example of how we can what we do with polyatomics in this situation, right? So I'm coming over here and I'm saying, hey, I got a lot of stuff going on. So I'm going to make a reactants and products table, and we'll start there. I have 1 sodium, 1 chlorine, 1 silver, and I'm going to keep my NO3, my nitrate, together because I see that NO3 stays together on the other side. So instead of breaking it down into like 3 oxygens, 1 nitrogen, I'm just going to put NO3. I have 1. Okay, so, oh no. So on the other side of things, look, I got 1 sodium, 1 NO3, one silver, and oh my God, one chloride. Amazing. So again, this is already balanced, but I want you to recognize how we set up this table and keeping that polyatomic intact, right? It'll make it 100 times easier, I promise. So to wrap this up then, since it is already balanced, what type of reaction is it? I see that I have a salt here, so NaCl, and I know that these do split up into Na plus and Cl minus, and then I have AgNO3. So a polyatomic with a charge plus our silver with a charge, and if you see, they're switching. So sodium is now paired with my nitrate ion, so one from each, and then silver is paired with chlorine, right? One from each. This is known as a double replacement reaction. Double replacement reaction. Where you have two different products, they kind of like switch what they're partnered with, and now you have a new one. Two new ones. Yeah. So, again, all of these answers are on Blackboard, but I hope this was beneficial going through it. Just take your time and practice.